Imagine this. You're standing on Earth, holding a rock in your hand that traveled millions of miles through space to get here. But this isn't just any rock, it's a fragment of Mars, a piece of another world that somehow ended up in your grasp. This might sound like science fiction, but it's a scientific reality. Over 200 meteorites found on Earth have been traced back to 5 impact craters located in 2 volcanic regions on Mars, Tharsis and Elysium. These regions are among the most geologically active areas on Mars, and the meteorites that originated from there carry with them stories from billions of years ago. But how did these rocks make such an extraordinary journey across the vast expanse of space to land on our planet? The story begins with catastrophic impact events on Mars. When a large asteroid or comet slams into the Martian surface, the force of the collision is so immense that it ejects massive amounts of material into space. These ejected rocks, now on a cosmic voyage, enter a solar orbit and some, by sheer chance, eventually find their way to Earth. To date, scientists have identified at least 10 significant meteorite launching events in Mars's recent history. These events are not just random. They are key moments in the planet's geological timeline, moments when the planet's surface was violently reshaped and its history was sent hurtling into the cosmos. Recent research led by scientists at the University of Alberta has provided groundbreaking insights into these Martian meteorites. By utilizing advanced computer simulations and studying the shock features, unique mineral transformations, and impact glass found in the meteorites, researchers have been able to pinpoint the specific craters on Mars from which these rocks were ejected. This breakthrough is more than just a technical achievement. It represents a significant leap forward in our ability to understand Mars's geological history. But what exactly are these shock features? When a rock undergoes the extreme pressures and temperatures associated with an impact event, its minerals can change in very specific ways. For example, quartz, a common mineral, can transform into a denser form known as stishovite under such conditions. These transformations, along with the formation of glassy substances from molten rock, are like fingerprints that scientists can use to trace the history of a meteorite. By examining these features in detail, the team at the University of Alberta was able to determine not just where these meteorites came from, but also the conditions under which they were ejected from Mars. This research is particularly exciting because it allows scientists to recalibrate Mars's geological timeline. By understanding when these meteorites were launched, we can better understand the timing of major volcanic and impact events on Mars. This could provide critical insights into the planet's past, including the periods of volcanic activity that shaped its surface billions of years ago. For instance, the Tharsis region, one of the 2 key areas identified in this study, is home to some of the largest volcanoes in the solar system, including Olympus Mons, the tallest volcano known. The fact that so many meteorites can be traced back to this region suggests that it played a major role in Mars's geological history. Moreover, the ability to trace these meteorites back to their origins on Mars has profound implications for future exploration. If we can identify the specific craters where these meteorites originated, we can target these areas for future missions. Imagine a mission to Mars where scientists already know the geological context of the rocks they are studying because they've been analyzing similar rocks here on Earth. This kind of targeted exploration could yield unprecedented insights into the history of Mars, its volcanic activity, and even its potential to have supported life. Speaking of life, the discovery of Martian meteorites on Earth has led to some intriguing questions about the possibility of life on Mars. Some of these meteorites contain microscopic structures that some scientists believe could be fossilized bacteria. While this interpretation is still hotly debated, it raises the possibility that life might have existed on Mars billions of years ago, during a time when the planet was warmer and wetter than it is today. If that's the case, studying these meteorites could give us our first glimpse of extraterrestrial life. Even if these structures turn out not to be biological, the mere fact that organic molecules have been found in Martian meteorites is still a tantalizing clue that Mars may have once been a habitable environment. But the implications of this research go beyond just Mars. By studying Martian meteorites, scientists can also learn more about the early solar system as a whole. Mars, after all, is a planet that has preserved much of its early history. Unlike Earth, which has been geologically active for billions of years, erasing much of its early history Mars's surface has remained relatively unchanged. This means that Martian meteorites could provide a window into the conditions that existed in the early solar system during the time when the planets were still forming. This research also highlights the incredible journey that these meteorites have taken. After being ejected from Mars, these rocks spend millions of years orbiting the Sun, gradually making their way closer to Earth. When they finally enter Earth's atmosphere, they experience a fiery descent, heating up to thousands of degrees as they streak across the sky as meteors. Most of them burn up completely, but a few manage to survive the journey and land on the surface. These surviving meteorites are then discovered by scientists and studied in laboratories where they reveal their secrets. But the journey of discovery doesn't stop there. The ability to trace these meteorites back to their origins on Mars has opened up new avenues for research. For example, scientists are now using remote sensing techniques to study the craters on Mars that produce these meteorites. By comparing the data from these craters with the characteristics of the meteorites, researchers can gain a better understanding of the processes that shape Mars's surface. This in turn could help us understand how other rocky planets, like Earth and Venus, evolved over time. Furthermore, this research has the potential to inform future missions to Mars. If we know where certain meteorites came from, we can target those areas for more detailed exploration. For example, if a meteorite is found to have come from a region of Mars that is believed to have once had liquid water, that area could be a prime candidate for a mission searching for signs of past life. Similarly, if a meteorite came from a region with unusual volcanic activity, that area could be targeted for a mission studying Mars's geological history. In addition to its scientific implications, this research also has a broader impact on our understanding of the solar system and our place within it. The fact that pieces of Mars have made their way to Earth is a powerful reminder of the interconnectedness of the planets. It also raises intriguing questions about the possibility of material exchange between other planets. Could rocks from Earth have made their way to Mars? Could they have carried life with them? These are just some of the questions that this research has sparked. So, what does all this mean for our understanding of Mars and the solar system? Could these findings help us determine whether Mars ever hosted life? Could they inform the search for life on other planets? The journey of these meteorites is just one piece of the puzzle in our quest to understand the cosmos, but it's a crucial piece, one that has the potential to unlock some of the biggest mysteries of our solar system. As we continue to study these meteorites and the craters on Mars that produce them, we will undoubtedly uncover more secrets about the red planet. But perhaps the most exciting thing about this research is that it shows us just how much there is still to learn. Mars may be a distant planet, but thanks to these meteorites, we can study it in ways that were once thought impossible. And who knows, the next meteorite that lands on Earth could be the key to unlocking even more mysteries about our solar system and the history of life itself. In the end, the story of these Martian meteorites is a testament to the power of scientific discovery. It's a story that reminds us that the universe is full of surprises, and that sometimes those surprises come from the most unexpected places. So keep asking questions, keep exploring, and keep looking up, because the next big discovery could be just around the corner.